We have to solve logs, yes. We have to solve logs. That's the last thing we have to do, and you've kind of almost already done them today. So you're in a great boat. Now, not a sinking boat, a great boat. That's where you are. Now, if you look here, it's in the Laws of Laws booklet. It's kind of in the middle. So, if you look here, this one has log base 9, log base 9. So, if it has log base 9 and log base 9, that screams, put me together every time. If it was log base 6 and log base 6, it'd be, put me together. Log base X, put me together. It doesn't matter. If they have the same bases, I promise you, they want you to put them together. I want you to, they want you to.
What do you do if it's not the same base?
If it's not the same base, then they would have to sit separately, which you'll see one in that review that I just gave out. I'll give you a question, the other question on it, where they're all a little bit different. But you'll see what you do when they're different bases. You can't put them together. You have to actually just do each one separate, which you'll see. Okay, hero cookie to you. All right, so we can only put logs together. There is one big rule that fits here. When the bases are the same, that rule you get. The other rule is you have to have plus or minus ones in front of the logs. If you don't, you have to take that number up as the exponent. Then you can put them together. Let's pretend, do not write this, it's stupid, I won't know what the answer is going to be. But if there was a 2 here, I would actually have to change this to an x squared, and then I could put them together. Do you see what I'm saying? There isn't a 2 there, so I do not have to do that right now. But if there was a number in front of the log, the only way you can put logs together is if they have the same base and plus or minus ones in front. That's it. If they have a number, you have to use power rule, bring it up. Then you got rid of the problem. But we didn't have that problem. This one's a nice one. Base 9, plus 1, plus 1. I can put them together. I go log base 9. And now they both actually go in the numerator because they both have plus 1s, right? So I'm going to get x times 3, or I like it better as 3x. So that's how I'm going to write it, equals 1. When I have one log, and I don't, the variables beside the log are in the base, I must always do what next? Convert to exponential. Before I convert to exponential, though, I have to state my restrictions, because beside a log or in the base, I can't have negatives and I can't have zeros. We agree? So what did we always do? We're always just going to take this 3x, whatever's in the bracket, and we're going to say it has to be greater than 0. Just needs to be positive. That's it. And then I divide by 3. Now, the only time your inequality sign flips is if you divide by a negative. Did I divide by a negative? No. X greater than 0. Boom. Restriction done. Easiest questions ever is if they actually ask you for the restriction. It's literally that. Now we can actually solve it. So, I convert to exponential. The base of my log becomes the base of my exponential. What's with it doesn't stay. But if this is a base, it needs an exponent. What's its exponent? 1. And it equals 3x. Then what do? Divide by 3. X equals 3. These are often in written response. Why? Because I can y1, y2 the crap out of this thing and get an answer. It would give me 3. Boom. I can check these. Why? Because it says solve. Whenever it says solve, I can y1. I'm trying to drill this home. I'm still not selling it. Feature's not sold yet. Like I'm selling it, but no one's buying it. That's what I feel like is happening. So when it says solve, one variable, y1, y2, find where they intersect. Every single time. You should walk away from solving knowing you did really good or you didn't. Right? And remember, you can plug them back in. So I could go log base 9 of 3 plus log base 9 of 3. That is actually 1. 1 equals 1. Boom. Left side equals right side. I can check every solving by algebra as well. Always have been able to since little on. Okay? That's it. Next page. They get a little more advanced. We're going to bring in some quadratics. Because why not? Whoa. Bless you. Did you puke or sneeze? I don't know. Okay. I have, paying attention, log base 5 plus log base 5. It screams, put me together. Every time they have the same base. Put me together. I can only put them together if they have base 5, and plus or minus 1s in front. Do they currently have that? Yeah, they do. So I'm going to put them together. I'm going to go log base 5, and then I'm going to go x plus 1 times x minus 3. In brackets, equals 1. What can I do in that bracket? I can FOIL. So I can go log base 5 of x squared minus 3x plus 1x is minus 2x minus 3 equals 1. We'll talk about the restrictions for a quadratic one tomorrow. I'm not overwhelming you. We're just halting on that. There are restrictions on this. We will deal with them tomorrow, okay? All right. What do we do next? Switch to exponential. Whenever I have a variable beside my log or a variable in my base and one log, switch to exponential. Base of my log becomes the base of my exponent. The only way it's a base is if it has an exponent. What's its exponent? 1. X squared minus 2x minus 3. So I get 25 equals x squared minus 2x minus 3. Chillax, I'm going to erase it. I don't know why I put 25. It's like vultures. You know what? You know what I want to do? When you guys ask me a question like that when you're doing your review, I'm going to react the same. It'll be fun. It'll be like dramatic.
Well, you should just be like, oh yeah, that's how you do it.
Yeah.
Just like make up a random.
Oh, I just keep going, and you guys will just crumble. It'll be a mess. It'll be like people lying on the floor in the fetal position, rocking back and forth. Yeah.
I'm mentally doing it.
Okay, so what do we do when it's a quadratic? This is just grade 11.
Get 0 on one side.
Get 0 on one side, everything on the other. X squared, take off your jacket, man.
No. I mean, like I.
Oh, you're tripping. Stop. Oh, this podcast is a joke. Okay, what times what equals negative 8? What plus what equals negative 2?
Negative 4.
Ah, yeah. X minus 4, x plus 2. My eyes are watering. And x equals 4 and x equals negative 2. Now, without restrictions, you can check these, just so you know. What did I tell you can't have beside a log or in a base? Negative, right? You can't have a negative. So you can go back right to the question and see if they would cause that. So if I take the 4 and I put it back, I get 4 plus 1, which is 5. That's okay. If I put it in this one, I get 4 minus 3, which is 1. That's okay, right? So this one's okay. Let's check this one. Negative 2 plus 1 is negative 1. Are you guys paying attention? Negative 2 plus 1 gets me negative 1. Am I allowed to have a negative 1 beside a log? No. So I circle it, I put a line through it, and I say? Extraneous, yeah. What's up?
Is like that the only time we can't have a negative, or if it's a base too?
Base as well. Yep. So the x in the base or the x beside the log have to both be positive. Yeah. So we can check extraneous without NPVs. Yeah. Yeah. It will error you. Yeah. It doesn't exist. So you can check these right into your calculator. Also, once again, if you y1, y2, you will only get 4. This one will not exist anywhere on that graph, right? So sometimes in order to force you to do this algebraically, they'll ask for the extraneous root. Because you can't find the extraneous root on your calculator. Yeah? Okay. Okay. One thing I want to go over just in case. What if it was like this first though? Log base 5 of x plus 1 equals 1 minus log base 5 of x minus 3. Yeah. So if it has log base 5 and log base 5, they're screaming, put me together. We agree? Can I put them together when they're on opposite sides? No. So what's the only way we can put them together? Is if they are on the same side, together. The only way you can put them together is if they're together. So your first step always is to move the logs together if they're not together. So then you would have just the question we started with. And you leave the one on the other side because you're going to need the one on the other side to convert. Does that make sense? Okay. What happens if they're all logs?
Oh, they're to the base 10.
Yeah. And if they're all logs, this is actually easier than when they're not. Watch. This is log base 10, log base 10, log base 10. And I told you if they don't have bases to often put the base 10 because then it'll screen put me together, correct? So you can do this two ways. I'm going to show you one and then the other way. The way that we just did it, this screams put me together, which screams what? Put them together. How can I put them together? They have to be together. So this is one way I could do it. I just have to move that one over. Yeah?
But if you're trying to put them together and they're already together, how can you put them together?
There's one not together.
You know what?
All right. So we have log base 10 of x minus log base 10 of 15. I'm going to show you the two ways. Minus log base 10 of 0.2. And what's it going to equal then? 0. So this is to do the method that we just did. I'm just showing you the same way. Then I'm going to show you the other method that you usually do when they're all logs in a second. But I want you to have two ways just in case, because sometimes they'll be like, student A did it this way. Student B did it this way. Student A is correct, student B is correct. Student A is correct, student B is not correct. Student B is correct, student A is not correct. Both of them are incorrect. Like they'll show the steps, and they'll show both methods. So you need to see both. So I can put these together because they have plus or minus ones in front, and they're all base 10. So I'm going to go log base 10. And then I go x over 15 times 0.2. I don't know why it's looking so wobbly, but whatever. Equals 0. 15 times 0.2 is what?
3. Wouldn't it be 15 divided by 0.2?
Nope.
Yeah.
If they both have minus ones in front, they just both go to the denominator. And when you have more than one thing in the denominator, you multiply them.
It makes sense.
Now what do? Convert to exponential. If you didn't have the base 10, you might sit here for life. And you might be like, I don't know how to convert to exponential. So make sure you put the base 10. Because the base of my log is going to be the base of my exponent. I need an exponent. It's 0. What's anything to the power of 0? 1 times 3. And I get x equals 3. What do I always have to do when it's a log? I must always check. Always, always, always. So I go back to the original and I say log 3. That's okay. And then there's no other variables. So it's good. Right? I also can y1, y2. I also can verify by plugging it back in. So that's the one way is I can move all the logs to one side set equal to 0. We agree? The other method that they say when it only works is only, it's going to be this one. The method only works when you have all logs. So I have log base 10 of x minus log base 10 of 15. 10, I don't know what I put next. 10 of 15, and then log base 10 of 2, of 0.2. If you have all logs, you can put the logs on the one side together and leave the other log. So if you have, this only works if you have all logs. The other example I did up top wouldn't work. So we have all logs. We can go log base 10 of x over 15 equals log base 10 of 0.2. Now if this is a true statement, what's true about this? Yeah, if it's log base 10 of x over 15 equals log base 10 of 0.2, what is equal?
X over 15 and 0.2.
Yeah.
That's what I started doing and then I got stuck.
So now you get x over 15 equals 0.2. This only works when you have all logs though, right? Only when you have all logs does this work, because now you have this log equals this log, so what's beside the logs must equal. And then I just multiply by 15, and it's 3. And I've already verified 3, so that's good. Okay? Flip over. So, what could we do here? We could move them all over. It's going to get real complicated if you move them all over. So what I'm going to do whenever there's all logs is I don't move them all to one side. I just do one log here, and then just solve them. That's what I will always choose. You can choose to move this over, set it equal to 0, and put them all together. You can choose that method. I will always do logs and logs. So I'm going to put this side together first. Plus 1, base 3, base 3. So I can put them together. I get log base 3 of x times x minus 1 equals log base 3 of 6. What can I do next? Distribute. So I can go log base 3 of x squared minus x. In this one spot it makes it all wonky. Equals log base 3 of 6. What could I do now?
Bring 6.
Nope.
Well,
Log base 3 of x squared minus x equals log base 3 of 6. If this is true, if log base 3 of this equals log base 3 of this, then those thises must equal. It's like common base for logs. So now I can say x squared minus x must equal 6. And then now I would move the 6 over. Because it's quadratic, get it equal to 0. X minus 3, x plus 2. Now some people might assume that the negatives never work. Sometimes the negatives do work. Like if it was like 4 plus negative 2, that's 2, that's fine, right? So you can't just assume that all the negative answers won't work. You have to check them back into the original. So if I take the 3 and I put it back, I get log base 3 of 3. That's fine. 3 minus 1 is 2. That's fine. So this one's good. Negative 2, log base 3 of negative 2. Done. Extraneous. What's my problem with example 5?
can you do it the other way though? I did it where I bought 6, I played the 6.
We'll practice those after. I just want to go through more examples. Yeah. What's the problem with example 5? You have a 2 in front. What do I need to do with it? Make it in the exponent. So I actually have log x squared equals log of 3 plus log of 27. And people will sit here for life because to me this doesn't scream put me together. But if I remember to add its bases, that screams put me together. So whenever a log doesn't have a base, I put base 10 every time. So I can put together the right-hand side. I could move any of these around. I can move them all to one side if I wanted to and put them together, set equal to 0, convert to exponential, right? All those are options. I'm just going to leave them sit where they're sitting and put them together. So I get log base 10 of x squared equals log base 10 of 3 times 27. And I multiply them because they both have plus 1s in front. And then I get log base 10 of x squared equals log base 10, you don't have to show this stuff, but I am, of 81. And then what happens? Yeah. If this is log base 10 of this equals log base 10 of this, then x squared must equal 81. And what I need to remember is when I take the square root, what happens? Plus minus. So I get x equals plus 9 and x equals negative 9. And what must I always do before I box these? Check them back in. So if I put a 9 in, this will be 9. If I put a negative 9 in, this will be negative. Now sometimes both of them work. Sometimes neither of them work. Sometimes one works. It's like Goldilocks and 3 bears. Really. Okay. What's up with A? That 2 is a problem, isn't it? So I'm going to move the 2 up. Now, this one doesn't have all logs, so I'm going to have to put them together, convert. What about this one? All logs, right? So I can put this side together and then set equal. So you're going to try these two. You try them, and then I will do them at the same time. Hmm? Divide what x?
The 27 divide x, divide x.
No, because then you'd have 81 over x and a 27, which is going to be super problematic. How do I have to solve this one? Quadratic formula. A, B, C. Huge hint on this one. Look what it says. 2 decimal places. That's a hint that it's a quadratic formula.
Well, they're screwing with you, it's actually using the quadratic formula.
It might not be, but usually not.
Oh.
Good thing is they give you the quadratic formula. There's the positive. What's the matter? I'm not asking her. You ask her. I'm not asking.
Well, I know that part goes in the power. Are you sure? What do you mean? Because it equals something. Oh, you have to do that. Why did you have to do it? Just don't talk about it.
Well,
Can you go back? Where was she driving? Was she at least like?
she's like, I'm not picture.
No. Yeah, so it's the same.
I think the draft is empty.
Yeah, you've done it to me. Sit down.
Okay. So you have to use the quadratic formula to get it. If I plug them back in, 29.72 will work, but negative 2.72 is going to be wrong right away there. Bless you. I'm going to tell you for B. With B, you could end up doing division if you want. Or you could make it easier on yourself and do what possibly? What's another option we could do to not have to divide x plus 1 by 2x minus 3? Could I just add this log over here? Yeah. I would just add the log over. So I would get log base 4 of x plus 1 equals log base 4 of 8 plus log base 4 of 2x minus 3. You can use it as a division if you want, but I like it better when they're multiplied. So if I have the choice to move that over and make it a multiplication, I'm going to do that every single time. So we get log base 4 of x plus 1. These have plus 1s in front. So I can get log base 4 of 8 times 2x minus 3. So I get log base 4 of x plus 1 equals log base 4 of 16x minus 24. Then you can set them equal, and this one's nice. You went from a horrific quadratic to a linear one. There's no quadratics on this one. And always make sure to check your answer at the end to see if it fits. 5 over 3 plus 1 is fine. 2 times 5 over 3 is 10 over 3 minus 3 is still fine. I don't know why I just boxed the 5 over 3, but whatever. So I'm just giving you ones just like this to practice. And if you don't practice them, it will fall out of your heads. So I would practice them tonight. I'm not going to give you a ton, I'm just giving you enough to practice. This is 5 questions. I'm not homework checking this week. If you choose not to do the homework checking this week, you're going to be pooched from the test. So there, we'll figure it out that way. Let's release somewhat of the homework checks onto you. This is 5 questions. I would just do them tonight because it solidifies this. It's 5 questions. 5A is all logs. A to D is logs with a number. Just 5 questions. You don't need to do 700. You just need to do 5.